We shall see the next problem on flat belts. A flat belt drive is required to transmit 20 kilowatt of power at 1440 rpm. The driver and the driven shafts are approximately 3 meter apart. The dimensions of the pulley mounted on driver and driven shafts are 300 and 450 mm respectively. So this is mm. The weight density of selected belt material is 9.7 into 10 power 3 Newton per meter cube. Allowable design stress sigma d is equal to 2 MPa and coefficient of friction is equal to 0.3. Determine width of belt if thickness is equal to 6 mm, length of the belt, initial tension in the belt, centrifugal tension in the belt. So they are asking us to find width of the belt, length of the belt, initial tension and centrifugal tension. So they have given data, we shall write the data. The belt given is flat belt. So the power to be transmitted is 20 kilowatt. Speed is 1440 rpm. The driver and driven shafts are approximately 3 meter apart. So the center distance capital C is equal to 3 meter. The dimensions of the pulley mounted on driver and driven shaft are, so driver small d 300 mm and capital D 450 mm. The weight density of selected belt material is 9.7 into 10 power 3 Newton per meter cube. Allowable design stress sigma d is equal to 2 MPa and coefficient of friction mu is equal to 0.3. Determine first one, width of the belt. If thickness of the belt is 6 mm, length of the belt, initial tension of the belt, TC and T naught, centrifugal tension in the belt, TC. So before proceeding with the problem, we shall find the velocity, pi dn by 60. Since they have given thickness, we shall consider thickness also. Pi into d plus t. D is 300 mm plus t is 6 mm into 10 power minus 3. Speed they have given 1440 rpm. So here speed given is of smaller pulley. So the velocity which we will get is 23.07. We have found the velocity. So since this is greater than 10 meter per second, we need to consider centrifugal tension. Next we shall go for the power. So before proceeding with the power, we need to find the theta angle. So we'll take the formula from page number 289. They have given the formula here. So on smaller pulley, the angle theta s is equal to, we shall take this pi minus d by c. So this is formula for radians and this is for degrees. We need for radians, we shall take this formula itself. So the angle theta in radians is given by 3.09. So we shall take the formula for power. For power formula here they have given 14.5a, page number 291. So we shall take this formula. The value of B we need to find out. Power they have already given 20 kilowatt. So T is 6 mm and V velocity is 23.07. So the allowable stress is 2 MPa. W they are given 9.7 into 10 power 3 Newton per meter cube. Velocity is 23.07 square divided by 10 power 6 into G is 9.81. E power mu theta. Coefficient of friction is 0.3 into theta is 3.09 minus 1 divided by so the value of B is 162.25. So by considering the standard table 14.9a, here they have given the standard table, specific friction surface rubber transmission belt, nominal belt width of friction. So here width of the belt we have got as 162 mm. So here 160, 180. So we shall consider 180. B has 180 mm. So this is from table 14.9a, page number 311. So they have asked determine width of the belt. So we have found out the width. Next we have to find length of the belt. So to find length of the belt they have given formula. Here you can see the length of the belt for flat belt drive or open belt drive. Length of open belt drive they have given the formula here. So we shall take this formula because here there is no angle. In first formula there is angle. So we shall take the second formula. L is equal to 2C plus pi by 2 into D plus D plus D minus D whole square by 4C. This is equation 14.2b. page number 290. So length of belt for open belt drive 2C. C is 3000 plus pi by 2 into D plus D plus D minus D by 4C 3000. So the length of belt is 7180 mm, or we shall keep in meter, 7.18 meters. Next, they are asking us to find initial tension in the belt, centrifugal tension. TC and T0 we have to find. To find TC, we shall take the formula of centrifugal tension. TC, page number 291, equation 14.3. Shall take this formula. TC is equal to WB TV square by 10 power 6 G. Equation 14.3E, page number 291. W they have given 9.7 into 10 power 3 into B is 180, T is 6 mm they have given in the question itself, into velocity is 23.07 divided by 10 power 6 into 9.81. So centrifugal tension we will get the value as 568.36 newtons. Here we need to substitute the value of B and T as mm. Here they have given 10 power 6, so that mm will be converted to meter by this 10 power 6. So for velocity and W we can substitute directly. Next we shall proceed with the initial tension. In page number 291, equation 14.8, they have given relation between initial tension and power tensions. We shall take this formula, square root of T1 plus square root of T2 is equal to 2 root T0. So this is from 14.8, page number 291. So we are unaware of T1, T2, T0, so we shall take the formula of power. Power P is equal to T1 minus T2 into V by 1000. So this is 14.5A, page number 291. So power they are given in the question as 20 kilowatts. T1 minus T2 into velocity is 23.07 into 10 power 3. So the value of T1 minus T2 we will get as 866.93 newtons. We shall call this as equation 1. And from similarly data handbook, T1 minus Tc by T2 minus Tc is equal to e power mu theta. The equation number is 14.3c, page number 290. We shall take this equation, T1 minus Tc by T2 minus Tc is equal to e power mu theta. So T1 minus Tc by T2 minus Tc. We have found out the value of Tc, so we shall substitute 568.36 divided by 568.36 is equal to, for e power mu theta, we can directly substitute as e power 0.3 into theta is 3.09. So T1 minus 568.36 is equal to, this value turns out to be 2.53 into T2 minus 568.36. So on rearranging this equation, we'll get T1 minus T2 into 2.527 is equal to minus 867.89. So we shall call this as equation 2. So on comparing equation 1 and 2, or we shall substitute the value of T1, we shall send this T2 to RHS and we'll substitute the value of T1 in this equation. Then we'll get the value of both T1 and T2 as 2003.5 newtons, and the value of T2 is 1136 newton. So we have found out both the values of T1 and T2. We'll substitute the value of T1 and T2 in this equation. We can find the value of T0. So T0 is 1539 newtons.